Next, we introduce Proto-TAI, a virtual prototyping application that enables novice designers to quickly externalize and iteratively refine preliminary design ideas. Here, planar shapes are assembled into meaningful 3D design abstractions and subsequently fabricated in physical media. The Proto-TAI system comprises of 3 elements. A pen and touch-sensitive tablet PC serves as both a sketching medium and a computational system. A depth-sensing camera tracks the user's mid-air hand movements. A flat screen displays the virtual environment where the 3D design gets modeled. In Proto-TAI, we utilize designers' natural ability to sketch with a pen and to spatially manipulate planar objects with one hand. Users can directly sketch on the tablet PC to create the profiles of the planar shapes required for the design. They can then utilize a non-instrumented planar-shaped physical proxy to metaphorically possess and spatially configure the shapes within the virtual 3D environment. For Proto-TAI, we used a cardboard cutout as the proxy and included a handle at its base for convenient holding and manipulation. Our system uses Knight middleware to track the proxy's 3D position and algorithms such as random sample consensus and principal component analysis to track its 3D orientation. Users can sketch the profiles of the planar shapes as free-form curves, polygons, or circles. These profiles can be moved around in the sketch interface so that users can directly observe the relative sizes between them before assembly. The profiles can also be scaled to adjust their sizes. During 3D assembly, users can provide direct spatial inputs through mid-air motions of the planar proxy. In addition, they can also use tapping or touching gestures on the tablet surface with a digital pen to indicate assembly events. By using a 3D cursor in the virtual environment, users can anchor a planar shape onto the proxy and directly control it through the proxy. A 3D design can thus be incrementally created by spatially configuring one planar shape at a time. During design construction, users only need to approximately define the relative positions of the shapes. Our system automatically infers perpendicularity, parallelism, and alignment constraints between shapes based on their proximity. Proto-TAI automatically creates notch joints between adjoining shapes in the 3D prototype. Individual shapes can thus be easily fabricated in a laser cutter and assembled on the fly to create physical models. We conducted a user study to demonstrate the usability and efficacy of Proto-TAI. The studies revealed that novice users with no prior experience in spatial interactions can begin applying our system almost immediately. In addition, they can also create meaningful design prototypes with minimal practice in short time frames.